You know how your phone can instantly find all the pictures of your dog or tag your friends in a photo? Well, for the longest time, that was pure science fiction. Because for most of history, computers were completely blind. They could capture an image, sure, but all they saw was a meaningless jumble of numbers. They couldn't tell a face from a frisbee or a cat from a car.
So what changed? How did we go from that total blindness to AI that can spot diseases in medical scans or even help power a self-driving car? Well, that's the incredible story we're going to unpack today. The story of how we finally taught machines to see.
To really get why the breakthrough was so huge, we first have to understand why seeing is so effortless for us, but for the longest time was basically impossible for a machine.
I mean, think about it for a second. You can recognize a dog in bright daylight or in a dim room, whether it's right in front of you or peeking out from behind a chair. It doesn't even matter if it's a breed you've never seen before. Your brain just gets it. A computer, on the other hand, it just gets a massive grid of pixels, millions of numbers representing red, green, and blue values. It's like trying to understand a novel by analyzing the chemical composition of the ink.
And there's actually a name for this problem. Researchers call it the semantic gap. It's this giant canyon between the computer's view, the raw pixel data, and our view, which is filled with meaning. A happy dog, a sunny park, the idea of play. For decades, bridging that gap just seemed completely out of reach.
So, the first attempts were, well, kind of clumsy. Researchers tried to give computers cheat sheets. They'd literally write code to detect simple things like edges or corners or specific patterns. It's like trying to teach a kid to recognize a human face by telling them to look for two circles above a straight line. Sure, it might work for a simple smiley face drawing, but the second you show it a real person's face, the whole thing just falls apart. The real world is just too complicated.
So the big breakthrough didn't come from a faster computer chip or some clever new programming trick. No, it came from a completely different place, neuroscience. And, get this, it came from studying the elegant way a cat's brain sees the world. Seriously, a cat.
This led to a whole new type of AI called a convolutional neural network, or CNN for short. Now, don't let the name scare you. The core idea is actually beautiful and simple. It's directly inspired by experiments from way back in the 60s, which showed that in a cat's brain, each individual neuron doesn't see the whole picture. Instead, it's responsible for one tiny little patch of vision, and it's only looking for one simple thing, like a vertical edge or a diagonal line.
And this is how it works. It's kind of like building with Legos. The first layer of the network is like a box of the simplest, tiniest bricks. It just learns to spot basic edges and colors. Then, the next layer takes those bricks and learns how to combine them into slightly more complex shapes, like a pattern or a curve. The layer after that combines those shapes into recognizable parts, like an eye or a nose or a car's wheel. And finally, the top layer puts all those parts together to see the whole shebang, a face, a car, or a dog. It learns to see from the bottom up.
But you know, a cool idea is one thing. You have to prove it can work in the messy, real world. And that proof came in a single, dramatic moment in 2012 that changed the field of AI forever. Okay, so picture this. The year is 2012, and the event is the ImageNet competition. You can think of it as the World Cup for computer vision. The challenge? To correctly identify objects in a massive library of over 14 million images, covering 1,000 different categories. It was, without a doubt, the toughest visual test on the planet. And for years, the entire field was basically stuck. They had hit a brick wall. The very best algorithms in the world were still making a mistake on more than 1 out of every 4 images. Progress was moving at a snail's pace.
And then, a team from the University of Toronto showed up with their CNN, a model they called AlexNet. And the results? They weren't just a little bit better. They were an earthquake. AlexNet dropped the error rate all the way down to 15.3%. It didn't just break the record, it absolutely shattered it, improving by almost half. No one had ever seen anything like it.
This wasn't just a small step forward. It was a giant leap into a new era. The entire AI research community had a collective realization, almost overnight. This was the future. Deep learning, powered by these brain-inspired networks, was the key. The game had completely changed. Okay, so a bunch of researchers got really excited about a competition over a decade ago. Why does that matter so much to you and me today? Because AlexNet's victory wasn't just about winning a contest. It was about unlocking a world of technologies that had been stuck in the realm of science fiction.
I mean, this is the world we live in because of that moment. The AI that can detect diabetic eye disease from a scan with the accuracy of a top-tier doctor, That's a CNN. The technology that gives a self-driving car the ability to see and react to a pedestrian, CNNs are at the core of that. Even the amazing generative AIs that create unbelievable images from just a few words of text, they all stand on the shoulders of this breakthrough.
But, and this is a really important but, as incredible as this new way of seeing is, it's not magic, and it's crucial to understand that it comes with its own set of unique and challenging blind spots. For one, these systems are incredibly data hungry. They need to see millions of examples to learn. They can also be surprisingly brittle. An AI trained on images of roads in sunny Arizona might completely fail in a snowy Swedish winter. And maybe the biggest issue is that they are often what we call black boxes. We can see the final answer, that's a cat, but we often have no idea how the AI reached that conclusion. And that lack of explainability is a huge challenge, especially when we're trusting these systems with important decisions.
So let's just pull back for a second. We've seen how a problem that stumped the smartest people for 50 years was finally cracked by an idea inspired by a cat's brain. We saw how that idea was proven in a single competition that sent shockwaves through the tech world, and how it now powers so much of the world around us. For many, many real-world tasks, computer vision went from an impossible dream to a solved problem.
But here's the really wild part. It turns out that the core principles that taught computers to see were even more transformative when they were applied to reading, writing, and understanding human language. And that is a whole other story, which we'll dive into in our next explainer.